Welcome everyone to this joint event of the UMass Computational Social Science Institute and the UMass Institute for Social Science Research. Today we're going to examine what makes interdisciplinary research proposals successful, and to guide us through this topic today, we have two extraordinarily qualified panelists that I will introduce in a moment. I do want to note that we are recording today's event, which will be later. The video will be posted online. And also the slides that Fay and Jim are presenting today will also be available after the event. Fay Lomax Cook is Professor Emerita of Human Development and Social Policy at Northwestern's University's School of Education and Social Policy. She also serves as a Distinguished Visiting Fellow at the National Academy of Social Insurance in Washington, D.C. From 2014 to 2018, Cook served as Assistant Director of the National Science Foundation, leading the Directorate for Social, Behavioral, and Economic Sciences. And she also directed Northwestern's Institute for Policy Research from 1996 to 2012. Our other panelist is Jim Kurose. He is Distinguished University Professor in the College of Information and Computer Sciences at the University of Massachusetts Amherst. And from 2015 to 2019, he served as Assistant Director of the National Science Foundation, leading the Directorate of Computer and Information Science and Engineering. Jim also served as the Assistant Director for Artificial Intelligence in the White House Office of Science and Technology Policy. We'll begin today with a 30-minute presentation that Fay and Jim have developed, and then we will move to questions. And if there are clarification questions, I think you should feel free to ask them, but in general, I think we'll be holding questions until the period after the presentation, where we'll open it up and really have, I think, a fairly freewheeling discussion. So without further ado, I will turn it over to Fay and Jim and welcome them. Thank you so much for joining us, both of you.
Great. Fay, why don't you go ahead?
Great. Wonderful. Well, next slide, please. We are just delighted to be here. And what our plan for the day is I'm going to give a bit of context, and then Jim and I will share what we're calling some pearls of wisdom and advice about research that is interdisciplinary and collaborative, in particular between the social sciences and the computational sciences. So let's get started.
And maybe Fay, just before we get started, we should probably say that Fay and I work very closely together. So, you know, the assistant directors at NSF probably spend about a third of their time working with other ADs and other directorates. And as folks will see, that CISE and SBE, I think, have becoming closer and closer together, and how wonderful it's been to work together.
Yes, absolutely it has. So I want to really begin by saying to all of you that I think it is a wonderful time to be a scientist. And in particular, it's a wonderful time right now because President Biden has elected and elevated the Office of Science and Technology Policy to a cabinet level agency. And when science is at the table in cabinet meetings, it really means that science and the science advisor is going to have a say in all kinds of decision making. President Biden has appointed an absolutely stellar science team. Eric Lander, a world famous mathematician and geneticist at MIT and Harvard Medical School, is also the founder of the Broad Institute. He will be OSTP director. And as associate director, it will be Alondra Nelson, president of the Social Science Research Council, and also a professor at the Institute for Advanced Study at Princeton. As his co-chairs of the President's Council on Science and Technology, called PCAST, President Biden chose two absolutely amazing scientists, Maria Zuber, who is a planetary scientist and helped map the contours of the moon and Mars, and is also the vice president for research at MIT. Francis Arnold won the Nobel Prize in Chemistry in 2018, and the two of them are chairing PCAST. Francis Collins will remain in place as director of NIH. Now, I hope some of you might have gotten a chance to see Biden's and Harris's presentation of the science team last Saturday. If not, you can see it on YouTube. But I've seen President Biden, then President-elect Biden, excited about a lot of things. He gets very excited about ideas, but he and Kamala Harris were just beside themselves with talking about science and talking about this stellar science team, what they hope they can achieve. Next. So Biden gives Eric Lander a historic Rooseveltian charge. And I'm calling it a Rooseveltian charge because President Biden, it was President-elect Biden, when he wrote the letter to Eric Lander asking him to be his science advisor, he reminded Lander that in 1944, President Franklin D. Roosevelt asked his science advisor, Dr. Vannevar Bush, how can science and technology best be applied to benefit the nation's health, economic prosperity, and national security in the decades that would follow World War II? Now, Vannevar Bush was in charge of science and technology during World War II, the war effort. That could have been the end of it. But Roosevelt really wanted to know, how can science and technology be applied to peacetime efforts? Vannevar Bush's response was a report called Science, the Endless Frontier. I had that book on my desk when I was AD for SBE, and Jim might have too. But the report is so important. First of all, Biden charged Lander to ensure that the nation can continue to harness the full power of science and technology on behalf of the American public. But what's so important about that report is that it really makes the case for government funding of science in the United States. And it charts the future of scientific funding by the federal government. What it also did is it really paved the way for the National Science Foundation. And so we have that report, Science, the Endless Frontier, to be thankful for a lot of things. So next slide. So President Biden noted that President Roosevelt gave Vannevar Bush 4 big questions and 4 priorities. But he said to Eric Lander, Biden said to Eric Lander, I'm giving you 5 big priorities. And the first big priority, not surprisingly, is public health. And the question is, what can we learn from the COVID-19 pandemic about addressing need related to our public health? And so there are all kinds of questions here. How can we use telemedicine to improve the healthcare and benefits for all Americans? How can we enable the rapid sharing of health information? What the COVID-19 pandemic has really done is it's like taken the cover off of inequalities in America, racism, incredible problems that have been simmering along, but it's like this pandemic has just made them all so visible. At the National Academy of Social Insurance, where I'm a fellow this year and also was last year, what we have learned is how the pandemic has exposed so many problems in our social insurance systems, like Social Security and Medicare and unemployment insurance and workers' compensation. We have a task force on how to understand the pandemic's effects on social insurance programs and what we can do about them. And just one example is unemployment insurance. And I would say to all of you that this continues to be a big problem. We all know how many people have applied for unemployment insurance, how unemployment insurance is different in each of the states. And this is going to be a time when we can look at social insurance programs and figure out what the problems are, why they're problems, and what we can do about it. A second charge has to do with climate change. How can breakthroughs in science and technology create solutions to address climate change? President Biden wants Lander to develop new zero carbon technologies that can reshape jobs and the marketplace. Third, technological advancement in industries of the future. How can we advance the development of technologies and industries that will ensure economic prosperity and national security? It's clear that new technologies from artificial intelligence to synthetic biology are emerging in increasingly rapid cycles that are just transforming our lives. And each one of those new technologies arrives with different promises and different challenges. And we need to understand those, and we need to understand how they impact job creation and equity and national security. Next slide. And the next priority, the fourth priority, is equity in the creation and benefits of science and technology. How can we ensure that all Americans from all racial, gender, and economic groups are drawn into the creation and the rewards of science and technology? We are well aware of the problems here, that Americans from all racial, gender, and economic groups are not being drawn into the creation and rewards of science and technology, and we need to figure out how we can do this better. Fifth, the long-term health of science and technology. How can we reimagine and transform STEM education, empowering teachers and deploying technology to enhance educational experiences? Science and technology have really flourished in the United States since President Roosevelt's work with Vannevar Bush, and President Biden is really committed to ensuring the long-term health of science and technology. So next slide. So then what can we expect? I think we can really expect more investment in science around issues of national importance. I think we can really expect funding to increase. We'll be mentioning Senator Schumer's act that he has proposed. We can also imagine that there is going to be more funding in the National Science Foundation and the National Institute of Health. And so what Jim and I want to tell you is that we really need to be prepared for this increasing infusion in funding. And so we have what we have called 13 pearls of wisdom or pieces of advice that we'd like to share. So I'd like to hand it over to Jim to share some of those pearls of wisdom.
Thanks, Fay. So I agree with Fay 100%. It's really a great time to be in science, and I think when we think about opportunities and funding and where our fields are going, I'm predicting the next 4 years are going to be and beyond are going to be really good. So Fay and I, in addition to sort of setting this big context, and we're going to come back to this again later, because when you think about writing collaborative proposals and centers and things like that, you need to know where the funding is. So we're going to come back to that. But we wanted to do a top 10 list of things that we wanted to talk about here. And there were so many that we could only distill it down to 13. And so we want to talk about sort of a little bit more about the big picture about SBE, social SBS and computer science. Sorry, those numbers 3, 3, and 5 don't add up to 13. So there's actually 7 proposal tips here. Then we'll talk a little bit about specific actions, maybe things we could do now, and then specifically some things about proposals as well. And these are informed not just by the time that Fay and I spent in Washington Science Foundation, but we've been faculty members longer than most of you also, and have been involved in interdisciplinary research also. So some of our faculty experience, I think, is integrated into this. And certainly for me, I've been at UMass my entire career. So, some of my UMass lessons might show up here as well. So I'm a computer scientist. So of course I want to start with computer science first, but I wanted to sort of show this big picture of the notion that if you step back and you say, where is the field of computer science been and where is it going? That I sort of think of computing as going through sort of phases. And if you think back to the 80s, there was a lot of emphasis in computing on sort of the artifacts that we built, the operating systems, the computer networks, databases, programming languages, the architecture inside your machines and things like that. Around 2000, there was more of a focus on applications. Still, we're building artifacts. It's important as a research area, but the web and social media, data science, the applications running in data centers. And I will tell you, starting about 2015 onwards, looking at computing and where I think a lot of the emphasis is, it's been moving more and more towards people. And I put this slide up just for this group here in particular, because I think this evolution of computing from, theory and artifacts into applications and then into people talks about this need for closer ties between the social sciences and computing here. And if you look, we're going to get to this report a little bit later, but down in the bottom right-hand corner, this is a 20-year roadmap for research in AI that came out just last year. And you can see the whole second part of this is all about the societal drivers. So, and Fay's talked about some of this: healthcare and quality of life, education, business innovation, competitiveness, scientific discovery, social justice, and policy. So, I mean, this is a field of computer science saying, hey, where our field is going has a lot to do with society and with people. So again, I think this talks about the importance of computing and the social behavioral sciences moving closer together. Now, this is a trend inside the NSF. So the top left-hand corner, you see what's called a Dear Colleague letter. These are things that you don't have to get a lot of formal approval to do inside NSF. So this is one that Fay and I wrote about how our 2 directorates were really keen on enabling additional collaborations between computer science and social behavioral and economic sciences. So that was in 2017. One of the big ideas that Fay had mentioned when we were sort of getting started here, the future of work at the human technology frontier. This is a very specific research, actually all of NSF program where CISE, engineering, and SBE and EHR education are all taking sort of leadership roles. This is actually led out of the SBE Directorate about, in the most recent call, computing helping to enhance human cognition, for example. Another example of how within NSF these fields are coming together. Last year, our 2 advisory committees, CISE has one, SBE has one, formed a joint committee where there are members both from CISE and from SBE. They held their first sort of joint workshop on harnessing computational and social sciences to solve critical societal problems. So you see the directorates are really working really hard to work together and to help the community work together. And so I think that, you know, what CSSI is all about, you're all in a really, really sweet spot right now, I think. So a third sort of, and this is the last big context thing, that center scale activities, including things like living labs, if I look at sort of budget documents and you know, recent legislation that's been passed, I think these are going to be more and more likely. So if CSSI and ISSR and others, if there are groups that want to do center scale activities, I think the next 3 or 4 years, 2, 3, 4 years are going to be the time. It's going to be a heyday of this. So there's something called the National Defense Authorization Act. This was the, if you remember, this was the only time Trump's veto had been overridden. So this funds the Defense Department, but it puts a lot of, you attach tons of other things into it. And there's something in here called the National AI Research Institutes, which are very multidisciplinary, that are authorized sort of under this law that was just passed. This is the 20-year in the middle, the 20-year community roadmap for AI research that's calling for mission-driven AI laboratories, 10 of them at $100 million a year. So we're talking about large scale, really a national effort to keep the United States competitive with, you know, what you see happening in China and in the EU, and you know, doubling and tripling and 10 times increasing the amount of investments there. And then you see the AI Institute. This is just a PR piece, but the Institute's proposals that have been coming out of the National Science Foundation. So this is the context. I think one of the things, the closer integration between our disciplines, and then also the opportunity for center scale activities. Okay, so the next 3 things are sort of some nitty-gritty things about collaborations that I think many of you know, but it was sort of, we thought it was good to sort of put them together because many of you are interdisciplinary researchers. I don't know if any of you know who's in this picture. They're 2 polymer scientists, because when I went to Google Images and tried to find a picture of 2 UMass professors working together, I couldn't find any on Google Images, okay? You can always find 1 faculty member and 1 student or a group sort of posing for a picture. But teaching together is a great way to, I'm saying this now personally, and I learned this as being one of the co-PIs on the NSF Engineering Research Center on collaborative adaptive sensing of the atmosphere, which, you know, had electrical engineering, computer science, social science aspects to it. And we learned about each other's disciplines by teaching together and by teaching research seminars together. So if you're looking at ways to jumpstart collaborations, there's no better way than to be teaching. And there's maybe one better way, and that would be to fund a student together, right? I think there are probably some graduate students here, but those of us who are faculty all realize that almost no research happens unless a graduate student's involved, right? I've collaborated with, you know, many people over my career, and if we don't have a graduate student, it just doesn't happen. So, you know, when I think about things that our campus could do, our deans, our vice chancellor for research, don't quote me on this, but, you know, activities or opportunities, if you want to jumpstart research, fund, you know, create a fellowship or find a way to fund a graduate student together to work on research that's going to be joint. That's the way these things happen. And then lastly, just sort of nuts and boltsy things. And these are pictures that were taken from the CASA, and, you know, the interdisciplinary CASA. We work very closely with Raytheon, for example, and the fact that there was a long-standing relationship there. I mean, they were major players for us. They've helped us with so many aspects of the research collaborations, the education piece, advocating for the state. So the way that, you know, I think we as researchers and as faculty members, we think about, oh, you know, I want to work with this person, I want to work with this person. We think about things on campus, but I think partnerships with industry, institutional partnerships with other universities and the state, especially if you think about center scale things, they're going to be absolutely critical to do center scale things. Okay, moving on now to a little bit more about grantsmanship and proposal hints. I'm going to lay out a few here, and Fay's going to do a few, and then we're going to wrap up and have discussion. You know, there's always a question, it's chicken and egg, right? How do you get started? NSF more and more is now offering the opportunity for planning grants. So Smart and Connected Communities, this is a, you know, a long-standing 10-year, research program that's funded both by the CISE Directorate and the SBE Directorate. Matter of fact, I think those two directorates are probably putting more funding than the others, and are probably the longest standing collaboration here. But there are planning grants, right? So you're not quite sure exactly what the problem is, and you're not going to promise to do this, this, and this. But there are grants that are typically on the order of 100K plus that give you a year or 2 years to actually do the planning, right? And that allows you, for instance, to potentially fund a graduate student to bring on some, to do travel and things like that. And so it's an opportunity to run a workshop, bring people together, figure out what the ideas are. And before you do a center scale grant or even a large scale collaboration, these are great opportunities. So this is a picture of the CISE program directors, and they're all smiling. And I put that up there because, I remember when I was a junior faculty, my department chair told me, you should go down to DC. So I'm speaking now to the junior faculty. You should go down to DC to meet your program manager. And I was like, I just wasn't sure I could screw up the courage to actually do that because, I'm an assistant professor. They have all the money, they have the expertise, who am I? But I went down, and actually she is my program manager then in the late 1980s, is still a program manager there. She's sitting there in the second row, is one of the sweetest, most wonderful person in the world and cares about faculty, right? And so the thing is that I always encourage faculty to go down to NSF. The pandemic will hopefully be over soon. We can travel, go down to NSF. There are other schools that bring faculty down as groups. So as AD, I met, once a month with a group of faculty who were coming in, and then they would meet with program directors. So, the program directors are there to help you, and they're really nice people. I was also told by my department chair, I should go and do that at DARPA, also the DoD. And I always felt like DARPA program managers ate faculty for breakfast. So I never got my courage quite up to go and visit a DARPA program director, but it turns out they're very nice too, as well. So I think going down to DC, telling them about your ideas, they're there to help. That's their job, and they enjoy doing it. All these smiley people. Okay, Fay, I think we're going to transition.
Wonderful. Yes. So that was great. And now we want to transition just to a little bit to think about what makes for a successful proposal. And Jim and I both think that, and he's already mentioned this to some extent, successful proposals begin with bringing faculty and students together around some common questions that can launch research ideas like the future of work, inequality, broadening participation. Convergence research is the term that really began to be used a lot when, in fact, it's one of the big ideas, convergence research. We really need to bring scholars, scientists together from many of the sciences. Questions are too big and too important for any one discipline to think they can address it on their own. So I think that one way to describe this kind of bringing together people is our process at the National Science Foundation in our developing the big ideas. The director, France Cordova, was committed to the fact that we needed to develop at NSF the big challenges for the future. So how are we going to do that? Well, her answer might be one that you could consider there as well. She said, I want each of you ADs to work in your directorates on what you think the two most important research questions are that will make a difference to society if you study. Come to Airlie House. She had reserved us rooms for 2 days. We weren't going to be able to get out. We had to work together. And she said, in 5-minute presentations, you're going to present your two big ideas and see if you can convince the other ADs that these are great ideas. You can't talk to any of the other ADs, but you can talk to your own directorate. So in social, behavioral, and economic sciences directorate, we had meetings. What are our big ideas? We had conflicts. We described all of this. And then I went to Airlie House with SBE's two big ideas. Our first big idea was work, the future of work, how to think about how work was changing in America with the gig economy and with Airbnbs, and industries were changing, work was changing. Our second big idea had to do with technology, the human technology interface, how technologies were influencing the lives of people and people were influencing technology. These were our two big ideas. Well, lo and behold, Jim had a very similar idea about the interactions between technologies and people and the role of computational science. Engineering AD had a very similar idea. And lo and behold, even the education directorate had a very similar idea. So this was a huge success. So
can I jump in, Fay?
Sure.
It was
did I give us in SBE too much credit, Jim?
No, not at all. I was just going to say what an amazing experience that retreat was that gave way to these 10 big ideas, because we did the same thing in CISE that SBE had done. Of course, rather than coming with 2 ideas, we tried to pitch 3.
I know, you were always just too much of an achiever, Jim.
Yeah, well, in any case, so we came in with one called the Human Technology Frontier, which matched so perfectly with the future of work. And as Fay said, engineering and education came in with something very similar. And then we came in with one on data science, which ended up becoming Harnessing the Data Revolution that SBE came in on. And I remember after we did our presentations, I looked and I said, actually, those 2 were the ones that I think there were 4 directorates all saying these are really areas where we need to work together and launch a big idea. So,
right.
So that was great. And the cybersecurity stuff never made it. That's okay.
But what is really interesting, Jim, is what we decided at the very end of that retreat. It was going to be about the human technology frontier. And then we got back to NSF, and France Cordova kind of was scratching her head, and she said, that's so huge. Can you tie it down to one area? And then there was another big decision point. What should we tie it down to? Should we tie it down? We had to make a decision. And so it ended up being tied down to work. And I really think that that was perfect. The future of work at the human technology frontier, joining these ideas together. And, that remains one of the most important ideas, but I think it's the model I want to stress of getting social and behavioral scientists together with computational scientists and saying, what are the burning questions in my field? And sharing those ideas, and as a result, coming up with burning questions that end up being convergent research. So let's go to the next slide. Jim and I could talk forever about.
Yeah, we want to make sure we want to leave a lot of time for questions and discussion.
Yes, absolutely. So another on successful proposals. Successful proposals should advance some aspect of both computer science and social science. need to address important questions in both the social sciences and the computer sciences. Next slide. And it has to really be true collaboration, and successful proposals are more likely to emerge if computer scientists and social scientists come together at the very beginning of a project where questions in theory development are just beginning. And so those two images on the right-hand side of refer to this: no stapled together proposals or no drive-by proposals. So what both of those X's crossed out are, is that we have seen a number of times where proposals come to us that are supposed to be collaborative work, where it really looks like the social scientist proposed the research and then realized, oh dear, in order for me to get this funded, I really need a computer scientist, or I really need a computer scientist to help us with the big data. Well, that's not going to work. It really has to be coming together at the very beginning of a project. So that's why I really gave you the example of how we did the big ideas. Get together at the beginning, so it's really true collaboration. Next slide. And it has to be a true team too. Successful proposals have teams with team spirit, and they've learned to speak the same language. So how do you learn to speak the same language? With some of the things that Jim has already talked about: co-teaching, co-advising, collaborating earlier. Jim and I had many laughs when we were together at NSF, because we would have these discussions also with the engineering AD and with the education AD. And we would waste a lot of time. I don't understand what you're talking about. And we eventually realized that we were just using different terminology for some of the same things. And
Actually,
so, yes.
I remember actually when we were writing something on the future of work at the human technology frontier, and you and I were the primary writers for that, you would write something and then I would completely undo it and write it a different way and send it to you. And then you would undo it and write it back to me. And it turned out we were trying to write the same thing, but words, I forgot what the word was, but there was a key word that meant completely different things to us. And so we were writing, we kept undoing each other's work. And it took collaborating closely to understand that a particular idea that we were talking about, we described completely differently.
Yes, absolutely. So we're going to the next slide now, and Jim's going to take over and talk about some near-term high emphasis areas.
Right, and this sort of brings the discussion just back to the very beginning and the context that Fay had mentioned. You know, having been at UMass for for 3 decades plus, when I think about collaboration and doing research, you need funding to do it. And so I always ask, where's the money, right? You rob a bank because that's where the money is, or you should know where the money is. And so, Fay talked about the Biden OSTP letter. There are a couple of other places where if you watch these documents, I mean, I'd never even heard of them until I went to Washington. And then I realized that, oh, you know what? Actually, agencies in the government signal what they're going to be doing ahead of time, and you just have to sort of watch these documents. So there's something called the President's Science and Technologies Priority Memo that I'm sure David remembers from his time in Washington. It's every summer it's released, and it's the president saying, these are going to be, Obama did it, Trump did it. These are going to be the areas that we're going to make specific investments in, right? Those are the kind of documents that you want to keep your eye on. And the OSTP, the Eric Lander letter from Biden that Fay mentioned also contains that, right? The pandemic-related research, the climate-related research. I mean, it won't, it's probably not a surprise to see either of those up there, knowing Biden, or the Biden platform, but seeing it now in memos, you see now the administration sort of walking down that step or walking down that path to say, okay, these are going to be the areas where we're going to put particular emphasis. Because of the economic challenges the country face, things that are work related. And I say this both within the state of Massachusetts, but also more broadly, research activities that are aimed towards the future of work, whether or not at the human technology frontier, issues of equity, social justice with respect to work, sustainability, privacy, those are going to be important. There's a phrase, industries of the future, which is coded. I mean, it's actually mentioned in the Biden memo. It's mentioned in the President's Science and Technology Priorities memo from the last couple of years. And it's also mentioned in the Schumer Act, what I call the Schumer Act. It's actually called the Endless Frontiers Act, that Schumer was one of the chief architects on, that's talking about tripling the NSF budget over the next few years. A key part of that is these industries of the future. So you can, I mean, that's just a list of the 10 things that are called out, but those are supposed to cycle through on 4-year timeframes. So anyway, just in terms of advice, I'm sure I focus way too much on funding and money as a faculty member, but you know, it is important to know where the increases in funding are likely to come. And these are our, you know, just based on these documents, sort of our guess on areas. And so, you know, if you think about the work that's going on that folks are talking about here in the two institutes, you know, you can find yourself in the middle of a lot of these things. So again, just coming back to the very initial remark that Fay made, it's a great time to be in science. It is a great time to be in science. There's a lot of important work to be done here that you see enumerated in these documents. So place to keep your eye on. So I think with that, we're all done. Sorry, we went maybe 5 minutes longer than we intended to, but we just wanted to open it up for discussion, and I think David and Ina will sort of help us moderate that. So David, Ina?
Thank you so much, Fay, Jim. That was wonderful. I think now what we're going to do is start taking questions from the audience. And you should be able to raise your hand to let me know that you've got a question. And then I will call on individual people to ask their questions. And so our first question comes from Bev Wolf. You can unmute yourself and ask that question. Take it away, Bev.
Thank you, guys. This is terrific. We always enjoy getting a little peek into NSF, and you have a lot of experience. So I have two questions, not in terms of importance, but I just wonder why security and privacy never came to the fore in the 10 big ideas. That's one question. But the other one is, where is education on all the things you listed? It's not in increased funding, and it's in the 10 ideas only if you push it, like you can push it into the future of work in terms of training. But in terms of education and education technology, I didn't see much. Could you explain?
Can I make a first stab at that, Fay?
Yes, please.
So Bev, the education piece actually is the fifth piece. It's really about it's cast in the terms of workforce.
Yeah.
So it's there as the fifth item in the in the Biden memo. You know, in terms of the big ideas, the future of work at the human technology frontier was, you know, part of the goal of that was to bring a big educational piece in. I think also every single big idea had an educational piece to it, but it wasn't pulled out separately. And we had a lot of discussions about, should it be pulled out separately as something, or should it be cross-cutting? And the decision was made to be cross-cutting because there were applications of that actually across all 10 big ideas.
Okay, so that's sort of what I thought, that if you do a future of work at the human computer frontier, you can do education, but it seems like not, or you're saying it's slightly in almost every other one, but it's not
in
really.
Almost every other one. You know, maybe it's not in, the only one I might be able to think of is, you know, the multimodal gravitational plus radio plus optical astronomy physics one, but it's in all the others. You know, just with respect to your question on security and privacy, so that was our third idea that we tried to push. But, you can only have so many big ideas. There's been, as you know, there's a large scale security and privacy program, interdisciplinary, that CISE has been running now for 10 plus years. It's the largest single program, and it's bigger than any of the big ideas. So it's a long-standing, and it's $70.3 million a year in 2019, right? So it's been running with a lot of money for a long time.
Okay, thank you very much.
Yeah, and I would just add one thing to what Jim said about President Biden's letter to Eric Lender laying out the 5 big priorities. I think education is really part of his number 4 priority, and that is the area that I mentioned was equity in the creation and benefits of science and technology. And the question that's in my slide, you can go back and look at, was how can we ensure that Americans from all racial, gender, and economic groups are drawn into the creation and the rewards of science and technology? And when President Biden and when Eric Lender talks about that priority, it really has a big educational component in it. The only way we're going to ensure that Americans from all walks of life are drawn into the creation of science is through education and making sure that education is more equitable and equal and good in this country. And so I really think education is there. But and this is what people have to do in proposals, I think. When you frame that proposal, you have to make sure that you see the connection and make the connection. I think of a proposal as a bit like an argument, why it's so important. So education is there, and certainly in the future of work, it's there.
And Bev, as you know, it's also in the Convergence Accelerator, right? So it's one of the first 2 Convergence Accelerator themes. And if you look at the Schumer bill, what the Schumer bill, a lot of that is about, the one that could potentially triple the budget, is to look at some of the nearer term things that you can accelerate research and get nearer term, big benefits out of, which is what the Convergence Accelerator was all about. And so, you see it there too.
Thank you very much, both of you.
So Brendan and then Katie.
All right, hi, thanks, that was great. I wanted to second, Jim, I think you mentioned internal fellowships at UMass for interdisciplinary work. Like if we had more of those, I personally think that would help a lot. It's there's a very small number now, and at least for me, it's made a big impact. And they really haven't been geared for this. The Institute for Diversity Sciences did a bunch of these seed grants. And like, I don't think on their mind was like positioning people well to get these joint SPE size things in the future, but I can imagine more of these at UMass.
Yeah, again, it's always great to have, Brendan, it's always great to have funding for graduate students. I think when you think about it, say put on an administrative hat and think about it from a programmatic standpoint, the goal here would really be to fund a graduate student so a collaborative research project can get going, and it's going to be geared towards, larger activities, right? So you make as a dean or as a provost or as a VCR, you make an investment, and hopefully that investment then brings even, bigger external investment.
Yeah.
So,
the seed grants did that.
That's the argument
Exactly.
for having that program.
Yeah, that'd be great. I guess I had a question about how you think or plans are, or how this will, these sort of joint social computational initiatives will happen within NSF. Will there be new programs, or will it be something that exists within current programs? So like I've had the experience of, we write a proposal for CISE, and we think there's some humanity social science outreach component of it. I remember we had like a broader impact of wanting to teach a tutorial at a social science conference to propagate these ideas. We got the comment from the program officer being like, no, you should serve our community. I think III in this case, being like, we should target for that. And I thought like, okay, well, it's a little disappointing for the interdisciplinary goals that I care about, but I see why CISE would think of itself in that way. So I guess I'm wondering, it seems like there's obstacles or challenges there, or maybe I'm just overthinking of it from a bad anecdote.
Well, this is being recorded, So I'm wondering what I want to, I was going to hand this question off to Fay, but since you mentioned III and that's in CISE,
Sorry.
I should say something here, but I'd love to get Fay's perspective here too. I will say that interdisciplinary collaboration and evaluating interdisciplinary proposals is something that NSF has struggled with, right? I mean, while Fay and I were there, there was RAISE and there was RISE, and that gave way to the big ideas. And I think the big ideas and the fact that there are very explicitly convened interdisciplinary panels to do the evaluation is a really good step in the right direction. But I will say that as an institution, NSF wrestles with that, right? And hasn't always been successful in doing it, right? You farm out a review to a particular program manager who does a disciplinary review, you're going to get that disciplinary comment that you mentioned, Brendan. So I think NSF is in a learning process. I don't think there'll be many people there who say, oh yeah, they've got it down and they know exactly how to do it. I think there is widespread understanding that it's a challenge and that NSF needs to and can do better. I don't know, Fay.
And yeah, I think it is a challenge, but I think that SBE and CISE really started working hard on this when Jim and I were there, and they are continuing. Jim mentioned, and I just want to emphasize the fact that the CISE Advisory Committee and the SBE Advisory Committee are meeting together regularly. And what's really important is CISE and SBE sponsored a joint roundtable workshop just this past May on collaborating together. And you can go on the web.
The URL is on the slide.
Yes, and you can, that's really important. And we can even share with you, because it's public, the slides that came out of that collaboration. And as a result of that roundtable, SBE and CISE are thinking seriously about what are the next steps. Now, we can't share right now what those next steps are going to be, but they're going to be some next steps. And I think it's important for you to take a look at the themes that were mentioned in that roundtable discussion that was last May the 19th, I believe, and think through that. There is, look, I think collaboration across disciplines is really difficult. It's something we struggled with at Northwestern University at the Institute for Policy Research, but it is really worth struggling with. I mean, as you well know, I mean, you asked the question, you're excited about interdisciplinarity. Questions are just too important. Problems are too important for any one discipline to think that they can address it on their own. And NSF knows that and really, really working hard to surmount those challenges.
So yeah, I might just emphasize one thing Fay said about maybe the importance of looking at what came out of that workshop, because if CISE and SBE do something together here, it will be based, I think it's a good guess would be, it will be based on the outcome of that workshop. So something, again, I never knew this as a faculty member, but now I know this, having worked at NSF, you'll always see, before new programs start, you'll always see workshops in the area. And so the question is, which of the workshops are going to give rise to new programmatics and which ones might not, right? And sometimes that's the point of the workshop. Is there a there, right? Now, if there were to be an announcement, there would probably be only 90 days to respond to it, or just after 90 days, because a solicitation has to be out there for 90 days. But you want to fund it in the current fiscal year, so there's usually not much more than 90 days notice. So if you want some advance notice, that if there were to be a program, looking at what happened at that workshop would be a good way to think, oh, okay, there could be something here, something here, something here. You never know till the solicitation comes out. But sometimes when the solicitation comes out, you only have 90 days to put together or 100 days to put a proposal together, which can be too short.
All right, Katie.
Great, thanks, Jim and Fay, for a great presentation. Having talked to folks that are interested in this like interdisciplinary collaboration, a lot of what I've heard is that there are structural incentives that really discourage people from building interdisciplinary collaboration, such as publishing in a journal that's going to count towards your tenure or your graduate student getting a job versus something that's not going to count at all. And so I'm just curious if you can talk from your own personal experience or from a higher level NSF standpoint about how to address these sort of like structural incentives that are really holding back this kind of interdisciplinary research.
Well, I'll start with that because I do agree with you that that is a structural disincentive, the whole area of publishing. And I'll tell you one way, not the best way, but one of the ways we tried to think about that at Northwestern. We would think about the products of a very interdisciplinary proposal and tell the social scientist, the computer scientist who was involved, look, it's okay to publish a piece of this in your own disciplinary journal. And just to carve out a piece for your own disciplinary journal and publish it there. But be sure that in the context and the framing of it, in the research design of it, even in the conclusion of it, you make clear that what's unique and special is that this evolved from a collaboration. Now, that's not the best solution. The best solution is if there were more and better interdisciplinary journals. But I know that now getting tenure is, getting tenure in the political science department or the psychology department or the sociology department, and they are recognizing publications in sociology, et cetera, their journal areas. But that's the way we have really emphasized it. And, I was director of the Institute for Policy Research. Policy research does not always get the best press. So again, most policy research does also address key disciplinary questions. And we would emphasize publish in your discipline if they're not the interdisciplinary journals. But in the framing and in the conclusion, talk about the implications for policy. And so we have been successful in that strategy. I don't know if, Jim, you have something to say about the whole issue of publishing interdisciplinary work in the computer sciences.
Yeah, I mean, I'll share a very, thought about this a lot. And you brought up graduate students, which I think is also really critical. So I'll bring up some personal reflections on that. One of the great things about being a faculty member is after you get tenure, you get to work on what you want, right? And you're passionate about it. And so that's what you do. So you do it, right? And that's great. But, pre-tenure, I think you have to be a little bit more careful, and you have to be careful with your students as well. When I was working on collaborative adaptive sensing of the atmosphere, so I'm a computer scientist, I published in the Bulletin of the American Meteorological Society, the Geophysics Society. I mean, none of my computer science colleagues had even heard of those journals, much less read them. And so they probably don't even know, except off of my AFR, that I might have published there. But that doesn't matter because it was really, really fun and made a difference. But for graduate students, I think that's probably, and maybe when you're pre-tenure, Fay's advice was spot on, right? Be thinking about disciplinary journals. I will say there are schools, and I think UMass is heading in this direction, where interdisciplinary is celebrated. Carnegie Mellon is an example of that. I went to Carnegie Mellon. I was talking, we were talking about research problems, And it took me 20 minutes to realize that there wasn't a computer scientist in the room and that they were all public policy people, right? And so there are schools, and I think a lot of schools are moving in that direction. So I think it's going to be easier. But right now, sometimes it's harder. And for graduate students, I think you have to be extra careful. And I'll just give you one anecdote there. So when I was working on collaborative adaptive sensing of the atmosphere, I had a graduate student who I was funding off of that grant. And I said to her, when you graduate, are you going to be a computer science networking person? Do you want to do things in, remote sensing? She says, oh no, I'm a computer scientist. And so honestly, I took her off of that grant and put her on a different grant so that she could publish a couple of papers that were specifically, much more, oriented to, the computer science discipline. She had a bunch of interdisciplinary publications. And I think that helped her, get it. She's a faculty member, tenured faculty member. So great. But we had to be very careful that she, published in the right places. And I think that's probably hardest for graduate students.
Great, thank you both.
Great, okay. Raichi.
Hi, thanks for the presentation. It was very informative. Fay mentioned that proposal submissions should speak the same language by being sort of a true team through co-advising, co-teaching across departments. And I was wondering if this teamwork is something that the proposal should ideally show evidence of at the time of submission, or kind of hint towards doing this in the future.
I'll make one immediate comment that is, if you don't have the common vocabulary, it's almost always evident in the proposal, and that's going to be really hard. A proposal that says we're going to work together as a team is going to be a much harder sell than when it's already clear that you've got a common vocabulary and a common understanding of the challenges. I think that's what Fay was saying.
Yeah, I agree. I agree.
Okay, that makes sense. Thanks.
Right, and in the worst cases, you see that in stapled together proposals, right? That the noun to talk about something changes depending on who wrote it, right? And, I mean, honestly, you see proposals like that, right? And those just stick. Those are the quintessential staple or drive-by proposals.
I see. Thank you.
Argus.
Yeah, thank you so much. This was really awesome for anyone who's interested in interdisciplinary research. I've been conducting interdisciplinary research, and everything that you see resonate a lot, like coming with, similar terminology. That was one of my biggest problem when I was working with architect. We were talking about design in HCI and design of the prototype. They were talking about design of neighborhood. So we realized that we don't really understand each other, and we need to be very clear and set up. So what I realized from that postdoc experience was that interdisciplinary research is very rewarding, but also very challenging. And it might take twice as much time that you need to work on your own discipline. So right. A lot of time, I feel like younger researchers, as you said, like PhD students need to publish and get out, and they need to publish in specific. This tension really distinguishes younger researcher and junior faculty to spend time on building and cultivating and fostering interdisciplinary collaboration. So a lot of advice that you gave are very, very useful in terms of coming up with a language, coming up with important questions. But in social science, I realized that a lot of time we're working toward a bigger goal, which is an impact, having an impact in a society. And a lot of time, it just takes good thinking about problem and questions and putting together different pieces of technology that might not be novel by itself, but they can have a greater impact. And selling those work to academic community, including NSF and publications, are very, very hard. And therefore, I feel like I myself have been a little bit discouraged. So I wonder if you have any word of wisdom.
So Nargis, What you say is absolutely spot on. I'll speak from a computer science perspective, and I'll also speak as someone who's been a chair and a dean, and done tenure and promotion cases for interdisciplinary people. I think that it's really, really important when you're doing interdisciplinary research, especially as a junior faculty member, that your department sort of understand exactly what you were saying about when you make that there's a contribution in putting both sides together. There's an intellectual contribution there. There's a document that was put together by the CRA, the Computing Research Association, on interdisciplinary collaboration when half of it is computer science, right? And it talked about, and if you can't find it on the CRA site, I can get it to you. But it talked about this issue of evaluation and spoke to each of those issues that you talked about. And I think that enlightened departments, and I believe ours is a very, very enlightened department, understand that now. It's been 20 years of learning that. I mean, that document's now almost 20 years old. But I think that computing now as a discipline understands, we're enough from moving from artifacts to applications to people that we understand that as a discipline. But if you want to see some written things on it, I'd encourage you to take a look at that white paper on, I think it's advice to departments, maybe also to faculty on interdisciplinary research involving computing.
Sounds great. Thank you.
Oh, I see somebody just posted, Mark just posted it's a best practices memo, right, in the chat.
Oh, excellent. Thank you.
So Fay and Jim, I have a question that is, I guess, NSF specific. When I'm writing a proposal that has a kind of interdisciplinary, it is to a program that is explicitly interdisciplinary, part of me is moaning, oh, this is so difficult. This seems much harder than writing one that is entirely within my discipline. But part of me says, oh, it's actually going to be harder for everyone else too, to write a good proposal that is truly interdisciplinary. Do you have any data or know, is there a higher acceptance rate, a lower submission rate for truly interdisciplinary programs, or are they about the same, or we may not know?
I actually don't know, though for those proposals that require convergence research or interdisciplinary research that make that as a comparison, I can't imagine that there would be a difference in acceptance rates if the very purpose of the Dear Colleague letter or the request, the solicitation, is for interdisciplinarity. But Jim, maybe you have more data or understanding of that.
David, when I think about CISE programs and acceptance rates in CISE programs, the programs that tended to be interdisciplinary, like smart and connected communities that, so SBE and CISE and engineering and EHR all participate and all put funding into that, that had a pretty high acceptance rate. The ones that I remember having sometimes being the hardest, actually smart and connected health, so that's interdisciplinary, but anything in machine learning, just because of the proposal pressure. So I wouldn't say there's necessarily a correlation there between, so I give you data points on both sides and saying there's no difference. So I don't think there's anything systemic there. But you're the causality expert.
Thank you. Thank you for that. Ina, go right ahead.
Yeah, thank you so much, Fay and Jim. This was really, really great. So I want to go back to one point that we've already talked about a few times about the common language. So Beverly, Shlomo, and Andrew, some others, we were on a team for the Convergence Accelerator Program. And I really found that when we were meeting regularly face-to-face and having our graduate students present, we kind of developed that common language. But right. Even in writing the proposal, just in the nitty-gritty of writing the proposal, and I think what you described about how you and Fay sent back to each other a proposal and kept changing it. I mean, in the end, it's so hard to write, a proposal in that same language. And I guess I'm just wondering, like, are there strategies? I mean, what you described, maybe it's just this back and forth, but particularly because we're all experts in different things. So we would write a little piece of it and it probably has a flavor of that stapled together. But I'm just wondering if, are there, and you've given us great advice, but do you have any kind of advice about like just concrete strategies to get that to work so that it doesn't look like a stapled together?
I think teaching together, talking together, funding, it's only by interacting that you have that. And so sometimes this notion of language could be a little abstract. So I want to tell a story, and it's a true story, okay? And it involves me and Kelvin Drogemeyer, who is just stepping down as the head of OSTP, but he was another co-PI on the collaborative adaptive sensing of the atmosphere, right? And he was leading the meteorological part, I was leading the computing part, and it talks about this issue of language. So we already had the center, right? And we were a year in, and Kelvin says in one of our, and we met together on a weekly basis, all 4 of our research thrusts, right? So we were doing all the right things. And Kelvin says at one of these meetings, he says, we need an architecture for the system, because we were doing things from designing radar forms all the way worrying about giving notification through emergency response managers and how people respond to that, and everything in between there, right? So it was an end-to-end system. So I thought that was a brilliant statement. I said to Kelvin, yeah, that's right, we need an architecture. And so Kelvin says, I'll do the architecture. And Kelvin's a meteorologist, right? He looks at, he models the atmosphere. He doesn't do architecture. So sorry, I didn't say that. But I said to him, I said, computer scientists are really good at architecture and abstraction, and that's what architecture is all about. And he says, no, I've built something, so I know about architecture. And I said, yeah, but I built stuff too, and that's what computer scientists do. And so we went back and forth, and we decided, okay, we would both go away into our groups, so we retreat to our disciplinary silos and decide what an architecture would look like for the system that we were building, because we had to deploy a tornado sensing system in the field with multiple nodes and things like that, and warnings. So we came back and we decided, okay, we'll work on this for a month and we'll come back and we'll show the architecture. And so we came back and Kelvin says, I'll show you mine first. And so Kelvin says, here's the architecture, okay? There's an Ethernet cable that comes down from here and it plugs into this RAID system for storage here. And then this goes out to a 10 megabit link for this and things like that. And it's an RJ45 jack. And I said to him, Kelvin, that's not an architecture, that's a wiring diagram, right? And he says, no, it's an architecture. And he said, well, show me your architecture. So you know what computer scientists do, right? We divide things into layers that are functional. We define the abstractions the layers implement. There's an interface. There are circles that talk about functionality and arrows between them. And so I explained to him that, and the different layers in the architecture and the functions and the interfaces. And he said to me, that's not an architecture. That is just, circles and diagrams with arrows between them. It's not an architecture. And that conversation has stayed with me now for almost 20 years. We had already been working together for 2 years. And it was only the fact that we were really down in the nitty gritty and deciding we needed to do this, that these 2 completely different interpretations of what an architecture was became apparent to me. To me, that's what really drilled home. I talked before a little bit jokingly about different nouns for the same thing. Well, that's a minor thing. Talking about architecture and for 2 years and having different meanings for it, that's
But Jim, you have just told a story about how incredibly difficult it is. So what we want to know is, how did you and Kelvin solve the problem of the 2 different architectures? So I want to believe that the way you solved it was that you saw how his architecture could fit within the layer cake of your architecture. There's got to be, Ina was saying, yes, this is really difficult. And you're just saying, yes, it's difficult, without saying, so how, we want to know the end of the story. How did it get resolved? I want to think it got resolved by the 2 fitting into each other.
No, it didn't. It got resolved completely because we needed a wiring diagram, right? you need to know that there's going to be an Ethernet cable that connects a Linux box on a spinning radar to a disk storage that's down below, right? You need that wiring diagram, and you also need the circles and the arrows. So in the end, we did both. Honestly, I think what we ended up calling an architecture was more the circles and the arrows, but we did the wiring diagrams too. And so, you know, we both saw the need for something, and we both called it architecture, right? And in the end, we ended up doing both of the things that we both agreed we needed to do. And again, to me, the real take-home message was the fact that we've been funded. We wrote an interdisciplinary proposal to get it funded at, you know, it's a $20 million center. It's a lot of money, right? So we went through the ringer about our interdisciplinary. We'd given talks together. We did a, you know, reverse site visit together, and we were under the microscope together. And yet there were still things we didn't really understand. So it is about the difficulty. On the other hand, I think what it also shows, you know, the solution that you asked for shows that, yeah, you need to do both of those things. And once we understood that, you know, I called it a wiring diagram, he called it an architecture, we needed to do both things, and we went and we did both of those things, and it worked out fine.
But what I would also add to Ina, and a response to Ina, is that you talked about the writing, and it's on, I mean, talking is wonderful. And I like what Jim said, because they both worked on the structure. I think the writing is really crucial. And what you're trying to do, each of you write something, but then sometimes trying to write the same thing and meld them together and revise each other's writing. That's the way Jim and I did it. And we kept revising each other's writing until we eventually
we had to meet in
were
person.
Exhausted. But we were eventually happy with it. So I do think you're writing and sharing writing back and forth and revising together for the umpteenth time is really what you're doing is the way to go.
Fay, I'm remembering now, we were talking, you would write in the sense of talking about studying something, and I was writing in the sense about building something. Now that I'm remembering that particular document, and it turned out that, you know, we were sort of using similar, I think you were using more passive language and I was using more active language, but it turned out we had sort of a fundamental sort of different views there that we ended up, I mean, I remember, you know, we'd send documents back and forth by email undoing what each other had done. And then finally we just decided, hey, we better sit down together and talk about this, and worked it out fine.
Yeah.
Thank you. No, that's great. And I think one thing this shows is it takes more time. I mean, and again, from my experience, like it's very rewarding, but this kind of back and forth and kind of keeping at it takes time. But, you know, it is rewarding in the end. So thank you. That was very helpful.
So part of both CSSI and ISSR's mission is to get faculty, you know, writing more proposals, and more, particularly in CSSI's case, more interdisciplinary proposals, although I know ISSR is also very interested in that. And we've talked about some of the ways that those kinds of interdisciplinary proposals are more difficult. What are the things that interdisciplinary groups can exploit that make their proposals more interesting, the research better? I mean, that they have, you provided a very strong argument that there is a desire for that research, and I totally get that. I'm also wondering about kind of what you can take advantage of to both write better proposals and propose better research because it's interdisciplinary.
I think one thing is that you need to show that unless this research is done together, that the question that both the disciplinary areas would not be able to answer unless they do it together, but really make specific, this is interdisciplinary, but neither group, neither part of the team could answer our question without the other and working together. and just make that really explicit.
Yeah, I think that's a great piece of advice, Faye. I think that, you know, whenever you write a proposal, you want to put it in the proposal what you want people to write in their evaluation so that it's very clear what the, you know, here are the intellectual contributions in each of those two disciplines. But I want to come back to what Ina said, and this is just a very tactical thing, right? That it takes longer, right? Now, you're a fabulous writer, David, right? But if you and Ina write something together, you know, you've got different language, right? And so you can't, you know, I could sit down with one of my collaborators and write a proposal literally overnight where at least it wouldn't look too stapled together, right? But you absolutely just can't possibly do that with interdisciplinary proposals, right? Because it just takes longer.
Thank you. That's great. Other questions? All right.
Well,
wow. Thank you so much, both of you. You have been just amazing, and the advice and the experience and the structure you put around it have just been fantastic. Thank you so much for doing this. I think you've inspired and educated a lot of faculty about how to go about writing these kinds of proposals in the future. And so applause. Thank you so much.